Okay, so this is an approximation of number 14a from the Chapter 11 Mastery. So it says a population of something grows continuously at a rate of 5% per time unit. Really, it says years in the problem. Approximate the time required to go from 500 to 3,000. Okay, so continuously compounding means I use what model? Yeah, I use the PERT population model. Okay, so how's the PERT population model going, guys?
P of t equals P of 0 E R.
Okay, cool. What things do I know?
The rate of time.
Okay, they told me the rate, that's 5%. So P of t is e to the, wait, how does 5% go in here?
0.05.
Okay, 0.05. What goes in for t? Nothing? Oh, did I make a mistake? What goes in for e? E. It's a number, man. Leave it alone, right?
Oh, you did.
What goes in for P0?
5.
500 seems reasonable. Okay, so I've got 500 times e to the 0.05 t. Now what do I do with this thing?
No.
No, this is your model. Okay? Stop. It's done. That's the model. Okay? So this is our model. Right? Check, done. Now, what do I do with the model? What were they asking?
The population. How long time?
From 500 to 3,000.
Yeah, when does the population hit 3,000, right? So what do I do?
Putting 3,000 for the T over here.
Oh no, you said it equals.
Oh,
Okay, wait. Is 3,000 an input or an output for my model? It's an output, right? You guys see that? I mean 3,000 population, not 3,000 years, right? If I wanted to know what the population was going to be in 3,000 years, I would cram t equals 3,000 in there. That'll give you a really big number. So I should put the 3,000 on the p side of the equation, right? Because it's an output. So I'm wondering, 3,000 is 500 e to the 0.05 t. You guys see that? On these, you should always ask, is the thing I'm looking for an input or an output, right? The thing I'm looking for is an input, so I'm putting the number they gave me into the other spot, right? The output spot. You guys cool with that? Okay, so now what do I do? Okay, so now I'm playing solve for t, right? So I apply divide by 500 both sides. What do I get? I get 6 is e to the 0.05 t. Now what do I do? Why'd you pick a natural log?
Because you have the e in.
Because there's a e, right? Okay, so I log both sides with the natural logarithm. I'll get, what do I get on the right hand side? ln is 6. Can you do any better than log 6? Like, could I put, you know, is there a way for me to figure out an integer that could go here? I could figure out a number approximately that goes there, right? That's a calculator. But I can't figure out a better number than log 6. At least not with an equal sign, right? So I got log 6 is
0.05 t.
okay, 0.05 t's. Now what do I do?
Divide your side by 0.05.
Okay, so we can either divide both sides by 0.05 and then figure out how to put that in our calculator, or we can get our approximation for log 6 and then divide that by 0.05. I don't care which one you do, they amount to the same thing. I'm going to divide by 0.05 both sides. So I'll get log of 6 over 0.05 is t. What's important here? In other words, what's the thing I could screw up? Yeah, okay, so if I punch log 6 into my calculator, right, I won't get a hard equal sign, I'll get an approximately. That's okay for this, right? Because I'm supposed to approximate anyway. Plus it's a model, it's an approximation anyhow, right? You guys see that? So on model things, it's totally okay to do the approximately equals. It's really fine. That's what you're expected to do.
If we have approximate ones on the test, does, like, are they all gonna have to be in the same kind of range?
Yeah, you should
Like,
round it
are you
about the
gonna get
same
it,
level.
Are you gonna get it right if you are in the basic range of it?
Yeah. So if you round to something slightly different than I round to, I'm not going to count on. I usually round to 2 places, just FYI. Okay, so am I done? Do I circle this?
No.
This is not really a good number of years, right?
No.
So I should get the approximately on this one. So what's log of 6? So how do you get log of 6 on your calculator?
Oh, yeah.
Okay, so I need a log button, right? And there's 2 log buttons on my calculator. There's a base 10 log and a ln button, right? So on this one, I need the ln button because I'm doing a natural log, right? So I push ln button, I push 6, and then if I'm going to put the divided by in there, I need to close that parenthesis. Right, so if you're typing this into a calculator, you would type, right, so the step from here to here is ln 6 parenthesis, which way does the slash go? 0.05. Is cool?
Wouldn't you have to put parentheses around the ln and the 6 to 7 times?
No. The calculator will group those things on its own. This is a function name and an input, so it knows it's got to do the rule to the thing before it does anything else. Say again?
35.83.
The whole thing?
865.18.
No. I meant this. You typed in the whole thing.
Yeah.
Okay. 35.83. Was I right to circle that?
You have to answer it, though.
Yeah, no, I just did something crazy, right? I should answer this in words. Okay, so how do I write the sentence? Yeah, time required is approximately 35.83. Am I getting a lot of credit in English class for this sentence?
No.
No, because it's kind of awkwardly constructed, right? I could maybe make it a little bit better by saying something like the time required.
No, but you also have to say the time required of what? If you
Yeah, so I really should add a unit on here. So I should say years. You guys see that? But I'm okay with kind of awkward sentences for math, as long as you phrase it in a sentence, right? This is a much less awkward sentence than that one. So I'm not looking for Pulitzer Prize winning writing here. That said, a better sentence would be awesome. A better sentence might be, the time required for the space colony's population to go from 500 to 3,000 is approximately 35.83 years. You guys see that? Or maybe is a bit under 36 years. You guys cool with that? All right.